Hello everyone. Have you ever noticed an elderly person holding their book far away from their eyes or a friend squinting while trying to read the board at school? These everyday moments give us a peek into some common vision problems, defects caused by changes in the anatomy of our eyes. Now, what exactly do we mean when we say defect of vision? Simply put, it's a condition where the eye cannot focus light properly, so the image formed on the retina, the light-sensitive layer at the back of the eye, is blurry or distorted. Imagine trying to watch your favorite movie on a fuzzy screen. It's just not clear, right? In fact, there are three main types of vision defects we encounter: myopia or short-sightedness, hypermetropia, which is long-sightedness, and presbyopia, a condition often related to aging. Each of these arises because of either structural or functional issues within the eyeball. Sometimes the eyeball may be too long or too short, or the curvature of the eye's lens might be off, or the lens may lose its ability to bend and focus properly as we get older. These changes mean that light entering the eye doesn't land where it's supposed to, right on the retina. Thankfully, we can correct most of these issues with the clever use of lenses, concave and convex, that help adjust the focal point, making sure clear images reach the retina once again. So, vision defects are not just problems, they are fascinating cues that tell us how wonderfully complex our eyes really are. Let's zoom in on myopia, or what we often call short-sightedness. Have you ever met someone who can read a book comfortably but struggles to see a distant blackboard clearly? That's myopia in action. This condition happens when the eye is a bit too long or when the lens becomes overly curved. Picture this: light rays coming from distant objects enter the eye, but instead of focusing nicely on the retina, they meet too early, in front of it. Because of this early convergence, distant objects appear blurred or fuzzy. Interestingly, myopia can be something you inherit from your parents, or it can develop if you spend a lot of time focusing on close objects like reading or screen time without taking breaks. The good news is that wearing spectacles with concave lenses, those are lenses that curve inward, can help by spreading out the incoming light rays just enough to shift the focus back onto the retina. This simple optical trick restores clear distance vision and lets you enjoy the world in all its sharpness again. Now, let's shift our focus to hypermetropia, otherwise known as long-sightedness. People with this condition can see distant objects quite well, but struggle with things close up, like trying to read or thread a needle. Why does this happen? Well, it's mostly because the eyeball is too short or the lens is too flat. When you look at nearby objects, the light rays entering your eye don't focus on the retina, instead, they fall behind it. This misfocusing makes close vision dull and can cause discomfort or even eye strain during near work. Hypermetropia is often present from birth, but it can also develop slowly as we age, due to a gradual reduction in the eye's ability to accommodate or adjust its focus. To correct this, convex lenses, those that bulge outward, are used. These lenses converge the light rays before they enter the eye, bringing the focal point forward onto the retina, and voila! Reading and close-up tasks become clear and comfortable once again. Let's talk about a condition that many adults experience after around 40 years of age: presbyopia, the aging eye problem. Think about those reading glasses you often see older relatives using. They need them because it becomes difficult to focus on nearby text. This happens because, as we grow older, the lens in our eye loses its flexibility. Along with this, the ciliary muscles, the tiny muscles that change the curvature of the lens, lose some of their strength. With a stiffer lens, the eye can't adjust properly for close objects, so reading or detailed work like sewing becomes challenging. What makes presbyopia unique is that it's caused by aging. Unlike myopia or hypermetropia, which can affect people at any stage. Also, presbyopia can appear alongside these other vision defects, making vision correction a bit more complex. That's where bifocal lenses come in, special glasses that combine two lens powers, concave for distance and convex for near vision. This clever design helps people see clearly both far away and close up, keeping our eyes sharp well into later life. Now, imagine looking at a picture that's both blurry and oddly stretched out in some directions. That's what astigmatism feels like. This defect causes objects, whether near or far, to appear distorted or smeared, especially along certain lines or directions. The root cause lies in the uneven curvature of the cornea, the clear front surface of the eye, or sometimes the lens behind it. Because the cornea or lens isn't perfectly round, light rays entering the eye focus at different points instead of a single sharp spot, leaving parts of the image crisp while others stay fuzzy. This uneven focus leads to discomfort, headaches, and eye strain. Astigmatism can occur by itself or together with myopia or hypermetropia, and it can be inherited or develop over time. Luckily, cylindrical lenses are specially crafted to tackle this uneven curvature by focusing light correctly along different meridians, giving us clearer and more comfortable vision. So, how exactly do lenses help fix these vision problems? It's all about bending light in just the right way to ensure it lands perfectly on the retina, where clear images are formed. In myopia, the problem is that light focuses too soon in front of the retina, so we use concave lenses, which spread the light rays out or diverge them, pushing the focal point back onto the retina for sharp distance vision. For hypermetropia and presbyopia, however, the light focuses behind the retina, so convex lenses, which converge light rays, bring the focus forward. And for astigmatism, the solution is a bit more specialized. Cylindrical lenses bend light differently along different axes to compensate for the uneven cornea shape, correcting the blur and distortion. Eye care professionals carefully measure these refractive errors during eye tests and prescribe lenses with precise powers expressed in diopters, a unit you might recognize from your glasses prescription. These lenses are then crafted to help our eyes focus just like they're meant to, letting us see the world in crisp, colorful detail again. Ever wondered how optometrists figure out exactly which lenses you need? During an eye test, they use instruments like a retinoscope or phoropter to see how light focuses inside your eyes. You'll often be asked to read letters on a Snellen chart at a set distance while the doctor tries out lenses of different strengths. By changing these lenses and observing which one gives you the clearest vision, they find the perfect correction for your eyes. This prescription shows numerical values such as -2.5 diopters for myopia that represent the strength of lenses needed. For astigmatism, it gets a bit more technical, including the axis, which tells us the exact direction of the cylindrical correction. Once prescribed, these lenses are precision manufactured and fit into spectacle frames, so every time you wear your glasses, light is accurately focused on your retina, easing your eyes and helping you see clearly without strain. Now, let's bring it all together. We've learned that myopia causes distant objects to appear blurry, usually due to an elongated eyeball or too curved a lens, and concave lenses correct this by diverging light. Hypermetropia is the opposite. Here, the eyeball is too short or the lens too flat, so images form behind the retina, and convex lenses fix it by converging light rays. Presbyopia is the age-related loss of lens flexibility, making near objects hard to focus on, and bifocal or progressive lenses provide tailored corrections for both near and far vision. Astigmatism, due to an irregular corneal shape, distorts images, and cylindrical lenses correct the uneven focus. Isn't it wonderful how such tiny adjustments in lenses can restore the marvelous clarity of our visual world? Our eyes are incredible biological instruments, and thanks to the science of optics, vision defects can be corrected, helping us experience the world as nature intended, clear, colorful, and full of detail. I hope this lesson has opened your eyes to the amazing biological processes within us and the elegant ways science helps maintain our sight. Remember, every cell in your eye and every ray of light that passes through is a testament to the astonishing complexity and beauty of life. Until next time, keep marveling at the living world around you.